How do you keep a PyQt UI responsive with multi-threading? Imagine working on a project and suddenly your application freezes just because it's busy doing something heavy. That's frustrating, right? Well, in PyQt applications, that happens when you run long tasks on the main thread. The main thread handles all the user interface stuff like clicking buttons or moving the mouse. When it gets stuck doing a big job like downloading data or processing images, the interface stops responding. Users can't do anything until the task finishes, which makes your app seem slow or broken. The trick is to move those heavy tasks off the main thread into separate worker threads. This way, the main thread stays free to keep the interface alive and responsive. PyQt provides tools like the QThread class and the QThreadPool class with QRunnable objects to help with this. When you create a worker thread, you put your long task inside it and start it. The main thread keeps running its event loop, so your app stays responsive. But remember, you can't update the user interface directly from a worker thread. Qt's GUI components are not thread-safe, so doing that can cause crashes or weird bugs. Instead, you use signals and slots. Your worker thread emits signals to tell the main thread what's happening, like progress updates or when it's finished. The main thread receives these signals and updates the interface safely. To keep everything working smoothly, always use signals and slots for communication. Protect shared data with synchronization tools like QMutex to prevent two threads from messing with the same data at the same time. When a worker thread finishes, make sure to clean it up properly by connecting its finished signal to delete later or similar methods. Never block the main thread with functions like wait because that stops the event loop and freezes the UI. A good pattern is to create a worker thread, connect its signals to your interface update functions, and let it run in the background. Python's global interpreter lock can limit true parallelism, but in PyQt, most of the heavy lifting happens in Qt C++ code, so threading still works well. Avoid using Python's native threading. Thread for GUI tasks because it doesn't integrate properly with Qt. Also, don't share mutable data without protection, or you risk corrupting your data. Always unlock your mutexes before your thread ends. Following these practices will help you build applications that stay responsive even when doing complex or time-consuming work. So, next time you're planning a PyQt project, remember, move your heavy tasks to worker threads, use signals and slots for communication, and keep your interface free to respond to user actions. That way, your application will run smoothly and keep users happy.